lesson. It's called the Pythagorean Theorem converse, or converse of the Pythagorean theorem. How does that work? Well, what is the converse? The converse of a statement switches the order of the if and the then in the statement. For example, if I started out with the statement, if a triangle has three equal sides, then it is an equilateral triangle. Well, the converse to that statement would be, if a triangle is equilateral, then it has three equal sides. So kind of it's very similar statements, but stated in a different way. So we know that if a triangle is a right triangle, then a squared plus b squared equals c squared. We learned that from the Pythagorean theorem. So if we're going to apply the practice from the above written information to write the converse of this theorem, here's what it would look like. And this is what it is. If a squared plus b squared equals c squared, then the triangle is in fact a right triangle. So if we have three lengths of three sides of a triangle, we can apply this theorem and to find out if it's actually a right triangle. So that's the idea of the converse of the Pythagorean theorem. So if we have these three sides, for example, then all we have to do is 25 squared, 24 squared, and 7 squared. And so let's get our calculator ready to go. So on a calculator, 25 squared is 625. So this would be 625. And that's if I square it. Then 24 squared would be 576. And 7 squared, I know by heart, that's 49. So now I'm going to add 576 and 49 together. And I end up with, when I add these two together, I get 625. So the two shorter sides squared and added together do in fact equal the longest side squared. That would mean that this is a right triangle. So it is right, okay? Well, let's keep it going. How about these three sides? Now, we did put the two short sides first this time, so we know this is A and B. So 4.2 squared plus 7.8 squared. If I do that on my calculator, 4.2 squared plus 7.8 squared, that equals 78.48. Now, so now I'm going to compare it with this other one. So 9.4 squared is 88.36. So we know that 9.4 squared and 88.36, that is not equal to 78.48. So we'll put a little not equal sign in there. So that means this is not a right triangle. If you were able to connect these three sides together and form a triangle, it would not have a right angle in it. All right, how about 8, 12, and 15? So 8 squared, 12 squared, so that would be 64 plus 144. And then 15 squared is 225. So if I add these first two together, do I in fact get 225? And just looking at it, the answer is no. You can see that you get 208 on this first one. And then on the second one, when you square it, 22x squared. Oh, excuse me, 225. That's 225. I dropped that 5 on accident. So anyhow, 5 squared, or 15 squared is 225. And so these two things do not equal each other. 8 squared plus 12 squared does not equal 225 squared. Okay, let's look at this problem. So we have 8 squared, which is 64, and 12 squared, which is 144. And if we add those two together, we get 208. Well, on the other hand, if we do 15 squared, we end up with 225. And so, because these two figures do not equal each other, this is not the three sides of a right triangle. So we put it's not right or not a right triangle. Okay, how about this one? We actually have the picture. We're trying to find out, is this a 90-degree angle? And it is if a squared plus b squared equals c squared. So let's check. 8 squared plus 3.9 squared. Is that equal to 8.9 squared? Well, 8 squared is 64. And then 3.9 squared is 15.21. And then 8.9 squared is 100. Nope, I think I did that wrong. 8.9 squared is 79.21. Well, when I add the left side together, guess what I get? 79.21. So this is a big yes. This is a right triangle. Nice work. Okay. All right, this one looks a little strange because it's kind of laying on its side. So what we're trying to do is find out if this is really a 90-degree angle or is this a right triangle. So we're going to do 11.2 squared plus 6.6 squared and see if it does in fact equal 11.6 squared. And just looking at this, I can tell that this number is nearly as big as this one, and we're adding to it another number, 6.6 squared. So I'm pretty sure this isn't a right triangle, just based on how big these numbers are. But we'll try it. So 11.2 squared plus 6.6 squared equals 169. So the left side of this is 169. And the right side, 11.6 squared is 134.56. So you can see that they do not equal each other, so this one is not right. So this is not a right triangle by any stretch of the imagination. Okay, how many more examples we got? We got 2 more examples. We can do it. So this one we're going to look at 9 squared and 5.6 squared. And we're going to add those together, but we're also going to show you a little bit of a shortcut. So if you do 10, the longest side squared, and subtract off these two smaller sides squared from the original squared, it is a right triangle if this quantity equals 0. So we're just kind of doing the problem in the same way, but just in a different approach. So 10.5 squared is 110.25. Minus 9 squared drops us down to 29.25. Minus 5.6 squared. Oh, when we check this, we end up with minus 2.11. So that was really close to 0, but not quite. So this is not quite a right triangle. Got close, but not quite there. All right, so to do these, then this is very similar. You just have to see if the two smaller ones squared equals the bigger one squared. And you can do that by using that shortcut I just showed you. So you can do 16 squared minus 13 squared minus 9 squared. And if you get 0, it's a right triangle. If you don't get 0, it's not a right triangle. It's that simple. So 16 squared minus 13 squared minus 9 squared. So this ends up coming out to be 6. So this is not a right triangle. All right, so let's do one more. I'll jump down to this last one. So 5 squared is 25 minus 4 squared, which is 16. And we're going to minus in that 3 squared, which is 9. All right, so 25 minus 16 minus 9. So 25 minus 16, subtract 9. That's 0. Oh, all right, so the bottom one is a right triangle. So the other two, B and C, you do the same way and figure out what you got. So we're doing Alex assignment number 84, the converse of the Pythagorean theorem. Thank you very much and good luck.